Okay, today we're going to review inequalities and absolute value kind of generally. I decided that rather than spreading this rest of the material over today and tomorrow, I'm just going to cover all of it today, and then there'll be two assignments. So today's assignment will be easier and tomorrow's assignment will be harder. But you want a chance to ask questions about it, about tomorrow's assignment. So I figured I'd better just go over all of it today so you have a chance to ask questions tomorrow. So this may be a little bit longer than normal. First, I want to review just graphing inequalities generally. So we've got things like this. In the previous video I did graphing I think just in one variable. So today we're going to do two variables, and we're going to do compound inequalities. Okay, so these both have two variables. It's a compound inequality. We've got two separate things joined by an or. So I'm just going to graph each inequality on the same coordinate plane. This one has a y-intercept of 0, goes to the origin, slope of 2, so I'm just going up 2 over 1. You graph this just like you graph a line, remember? But I'm going to make it dotted because it's less than. It's kind of steep. Okay, and I would shade below. I'm going to just draw this one first. This one starts at -2. It has a slope of 1, so it's going to go like this, and it is a solid line because it is greater than or equal to. Alright, so it seems like most of the graph is going to end up shaded because we're shaded below this line and above this line. So the only part that's not going to be shaded is actually right in here. Everything else is either below this one or above the other one. So it's just that region that's not shaded. Okay? Let's see. Let's do one with an and, just so you remember it's a little different. Y is greater than x minus 3, and this just means and y is less than 2x. Okay, so these are both already solved for y. They're in their slope-intercept form, so we're going to just graph them down 3, slope of 1, dotted line. Okay, and definitely don't do your shading first if it's an and, because part of it you'll end up having to erase. So here we got no y-intercept, so through the origin, and it's going up 2 over 1, and it's so dotted. Okay, and it's greater than this one, so above, and less than this one, so below, so it's just this region in between, and after they intersect, there wouldn't be any more shading. Yeah, that's that. Okay, so ands frequently have less shaded region. Not always, not necessarily. Alright, let's do graphing an absolute value equation. Or actually, we'll solve it and graph it. That'd be good. So it might say solve, and solve, it doesn't, it's kind of complicated. This has multiple solutions, so technically one solution would be to solve this, but implied in absolute value problems is supposed to find all the solutions. So usually that would be written, I'm just going to write solve and then graph. Okay, so first we're going to isolate the absolute value portion. To do that, I'm going to get rid of this coefficient by dividing by 1/2 or multiplying by 2. That means the same thing, however you want to think about it. And again, that's because we need to divide dividing by 1/2 turns into multiplying by 2. Okay, so this cancels, and this becomes 14. So the absolute value of x plus 2 equals 14. Now I'm going to split this into two separate equations. This is an equal sign. So x plus 2 equals 14. That's the case where the absolute value, this is already positive, and then it also could have been a negative 14 in here, so we have to solve for that possibility as well. Okay, so the first one, we're going to subtract 2 from both sides, and that's going to be x equals 12. And the second one is going to be x equals negative 16. So, oh my, negative 12. Yeah. What am I doing? Yeah, 12 and negative 16. So. Yeah, that's right. Okay, so we're going to graph that. I did want to show you something that's going to be a little unclear in this example, but here's 0, here's negative 16, here's 12. Okay. Yeah. Now I didn't teach you this before. I kind of thought about it, but I really want you to learn this solving part of it. But there is a kind of cheap way to do this, which is you kind of think about this the same way we think about like two variable things. Like this 2 would shift the graph to the left. And that is oh so true, actually. Like the same thing does work in one variable. I just didn't teach it to you. But you can think about this as shift it left 2, and then there's like a tolerance of 14, like it goes 14 in either direction. So that is another way to graph these. You kind of cut to the, like you don't have to do any of this stuff. You just say, okay, go left 2, go over 14, go over 14. And that is another way to graph these. It just, I don't know, it's a little I don't know. There's chances to make mistakes here, both comprehension and process. So I think this is a better way to go about it. But that is another way to treat this like a shift, a horizontal shift. And then this is a kind of range or tolerance. Okay, but those solutions are here at negative 16 and positive 12. Okay. Next one. Ask me a question about that in the question and answer if you didn't follow that explanation of that second one. But I'll be happy to explain it again. Okay, so next one. Do I want to do that? I guess so. Yeah, let's just do another one of these. They're worth doing. I guess this is an inequality, so that's why I put it on there. Okay, so you solve it just the same as if it was an equation. So first I'm going to get rid of the coefficient. I'm just noting that if this was negative, this would change direction. It's not, so I'm going to leave it how it is. Okay, 6 over 2 is 3. This goes away, right? So now I'm going to do my two different possibilities here. It could either be x minus 1 is less than 3, or it could be x minus 1 is, don't forget to change the direction of your inequality sign, greater than negative 3. Okay? And that's just accounting for, again, the two possibilities, one where this is positive, one where it's negative. And now we're going to add 1 to both sides. So x is less than 4. And because this is less than, it's going to be and. X is greater than negative 2. Okay. Yeah. So we're going to graph that. So solve and graph. This is kind of a solution, I guess. I mean, it shows you what the solutions are anyway. The graph is a little more clear, I think. So we're going to go from 4 and -2, and it's going to be in the middle because it's got to be bigger than the negative and smaller than the positive. So 4, -2, and it's in the middle. Okay, so 0 over there. Yeah, my circles are open because it's not or equal to. Right, and again, that same method with this one, I guess you could have used it, so this would be, you shift it to the right 1, so the center is here on 1, and then you go 3 in either direction, and draw your line, and then just note that they're open circles, and you're shading in because there's less than. So you can use that kind of shortcut graphing method here too, I guess. Okay, that's that. Of course, if it had been greater than, they go out. Or instead of in. Let's do graphing an absolute value equation in 2 variables. So y equals -3 times the absolute value of x minus 4. You need a minute to pause the video, write some things down, check your notes. I encourage you to do so, because this, I'm really covering a lot of stuff in this one, and I appreciate that might be hard to follow. Okay, so this is already solved for y. I'm going to graph this. You can't, there's no single solution because it has 2 different variables. So you can just draw a graph showing all the possible combinations of x and y that solve it. And it's ready to graph because it's solved for y. So I'm going to look here and here first for my coordinate of the vertex. So you can have a vertex because it's an absolute value equation. And the reason it's going to have a vertex and a V shape, if you don't recall, is because when you plug in values for x, what's going to happen is it's going to start out positive at -infinity because -infinity becomes positive infinity. And then it's going to come down, and at some point it's going to get to where the value of this is 0. And then it's going to go up because this is going to go back into the positives. So that's why you get that V shape. So we're going to go right 4. Remember, this is sort of inverted. Negatives make it go to the right. And up 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. And there is my vertex. Now my slope comes from the coefficient in front of the absolute value sign. It's a -3, so I'm going to go down 3 and over 1. And you can go over in either direction with the absolute value because it's going to go down 3 and over 1 on the other side too. Okay, and this is an absolute value equation, so all I'm doing here is drawing a line. I know we've done so many different things, different kinds of graphing, equations, inequalities, absolute value, not absolute value. It's really, I think it gets hard to keep track of after a while, but it's just an equation, so there's no shading involved. This is just a line indicating the solutions. Yeah, the absolute value is what makes it the V. Okay, so that is that one. Yeah, that's all there is to it. Next, we're going to do a compound absolute value inequality, kind of putting it all together here. Y is greater than the absolute value of x, and y is less than 1, let's do 1/4. Do that differently. 1/4 absolute value of x plus 5. Okay. Is that going to work actually? Yeah, that should be good. Okay, so they're both ready to graph because they're both solved for y. The first one is just the standard form. Whoops, that should be a dotted line. Sorry. Okay, and we're going to shade above, but I'm going to wait because this is an and, so not all that region is necessarily going to be shaded. Now I'm going to go, let's see here, 0, 5, up 5, 1, 2, 3, 4, 5, and my slope is 1/4. So I'm going to go from here, up 1 over 4. That's like here, and here. Okay, and that's a dotted line as well. So I guess they're going to intersect sort of in there somewhere. Something like that. Okay, and we're shading above this one and below this one. So the shading, if it's an and, is just where they overlap, is in the middle. So you got this kind of, I don't know, arrowhead shape thing going on. And that's all there is to that. So that's, yeah, that's really putting it all together. We've got absolute values, inequalities, and a compound statement there. So you can do those ones. You probably understood most of what we did during the distance learning unit, I guess. Cool. So I'll put up an assignment with that kind of stuff, and then yeah, again tomorrow there'll be another assignment on just the same material. I'm not sure if I'll do another video or not, honestly, but yeah, I probably will. But it'll just have the same kind of problems, but they'll be a little bit harder, like more complicated terms in them. And then we'll have our exam on Friday, so be ready for that. Okay.